Over the next couple of weeks, I want to post a series of short videos where we look at some early integrated circuits. And instead of looking at the sort of Western early integrated circuits like the LM709 or something like that, we're going to look at some early Eastern integrated circuits. And today we're going to start with the MAA245 by Tesla. This is actually a very simple IC. It contains exactly 3 transistors and 2 resistors. So it's fairly simple analog IC, and we're going to look at that closer. And over the next couple of weeks, we're going to look at some more of these. Tesla made all sorts of very, very interesting circuits. And I think very little has been done to actually bring them into the present, or just to show what you could do with these. So one big hurdle for most people is obviously that there's no English datasheet whatsoever, or at least I don't know of any English datasheet. So we'll just have to go with this, which is the original Czech datasheet. These were all made in Czechoslovakia, and I don't think these were available in the West at the time. I don't think they exported them. They exported them to obviously a lot of Eastern countries, and they were used in a fair bit of equipment. But I don't think they made it to the West a lot. At least I've never seen them. Interesting about these ones that I have is this little marking on top here of 2 crossed swords. And as far as I've been reading up on these ICs, this means, and they're all marked like this, that these were meant for the military. So this is military surplus. So let's look at this datasheet. So the 245 is down here. You can see this is inside this box here, which represents the package. We've got only 3 transistors, and these are all DC coupled to each other. 2 resistors of 3.5K. And then we've got the connections for the base of the first transistor coming out here, the emitters, and the collector of the last stage is brought out here, and then also this connection here for the supply voltage. So what you could do with these, I found a couple of example circuits online that were fairly interesting, but what we're going to do today is just build this simple example circuit from the datasheet. And what this is just an amplifier. So we've got the power supply coming in here, and it's supplying all these transistors here. The output voltage we're going to get from pin 2 here. So from the collector of this last stage transistor. And you can also see that we've got one resistor here and a capacitor to filter the voltage for these first 2 stages to get it a little more free of ripple. Here we've got a feedback resistor, and also we've got an input coupling capacitor here that couples this external voltage source into here. And I think somewhere down here it says something about at 12 volts at these parameters we could get a gain of about 80 dBs, that's quite a lot. 80 dBs is quite a lot. So what I did is I modeled this circuit up in Eagle, and I just copied this circuit that we saw in the datasheet more or less exactly onto a board. I changed the capacitor values here a bit, but this shouldn't matter too much. The resistor values, I think, I left as they are in the datasheet example. And then I made a board, and here we are. This is the board. You can see our military marked IC down here. 2 capacitors for the input coupling. In the datasheet, they use film cap or something like this, but this is just an example circuit just to demonstrate what this IC can do. And I didn't have a fairly large film capacitor, so I didn't use one. Alright, so what we should do is hook this up to power. And for this I'm going to use the analog power supply, the linear power supply for analog circuits that I built in the last, or I think one of the previous videos. Obviously you could also use this for digital circuits, but I made it really with this circuit in mind because this has a very high gain and I couldn't get it to work with the power supplies I have around because they just had too much ripple on them. Okay, so this down here is the input connector, and I'm just going to hook this up to my signal generator, and this I'm going to hook up to ground over here, and then what's left to do is to connect the oscilloscope up. And I'm just clipping this to the ground plane, which for signal integrity reasons is probably not the best thing to do, but it should be fine. Alright, so here we have our circuit on the test. Just off to the side just a little bit, because the probes aren't long enough. Right, so I put the circuit board in a little holder so you can actually see the circuit board while I'm explaining some things. The signal generator coming up here, in here to the input, is set up to produce 1 volt at 1 kilohertz at the moment, and the impedance is set to 600 ohms. But since this amplifier has such a high amplification, I've also put an attenuator in between, and it's providing 60 dBs of attenuation. So if we look at our datasheet again, if we're roughly in this sort of region, we should still get quite a bit of gain. So 1 volt through a 60 dB attenuator should be, I think if I remember correctly, about a millivolt, and we should expect to actually see the output signal on the oscilloscope pretty clearly. The input probe here I've got to set to ×1, and the output I've got to set to ×10. So if we look at the actual oscilloscope picture up here, we can see that on 5 millivolts per division on channel 2, which is the lower channel, which is the input here, we can hardly see the input signal. Which is, it should be peak to peak about 1/5 of a division, and it's about that. It's hardly visible. But I can very clearly see the output signal, so this is quite impressive. That even though this setup is not quite ideal, we're getting the very, very faint signal in there, and we're getting, considering the circumstances, we're getting a fairly clean output signal. I mean, I'd hardly call it clean if this were a proper setup, but it's still quite impressive that an IC that's old as this, it's just a couple transistors on a not exactly ideal circuit, and it's still giving us that amount of gain, a fairly clear signal. So, can obviously, I just fed in a triangle wave, but we could also obviously put a sine wave in, and we'll get just about the same. Another interesting thing we can do is we can go over to the signal generator, and we can turn up the frequency quite a bit. We obviously also have to change this on the oscilloscope. I should probably do a video next time so you can actually see how the trace on the oscilloscope changes. But I've put this up to about 50 kilohertz, and you can see it's still fairly visible and it still works okay, but we lost a lot of gain. I actually had to change the vertical scale from 0.5 volts per division to 0.1 volts per division, and it is obviously a lot less gain at the higher frequencies. Although I've read up on this chip, and you're supposed to be able to use it into quite high frequencies, but all of this really looks sort of like it's meant for the audio range or not far above that. So what we might do next time is build something cool with this and one of the other circuits I want to show off in this sort of mini series on these old analog integrated circuits. I could imagine quite a few things that this would be useful for. I don't think it would make a really, really good audio amplifier, because usually the gain that is needed for these circuits is not that high these days, except if you're building a phono preamp, but I wouldn't want to build a phono preamp with this. But I thought around a little, and maybe Geiger counter preamp or something like that. That could be interesting. Although in the book of circuit examples that I have, they also have a couple of audio circuits with this. Might be interesting to try those. They also give a graph, which I'll also put up here, that gives you the total harmonic distortion in relation to the signal and the input voltage. And it's not as bad as you would think. It's pretty okay, actually. So, yeah, this was a short video on this cool old integrated circuit. And next time we'll do another one of these Tesla ICs. So I'll be glad if I see you around.